Hi, 7th grade. Okay, today we are going to be doing lesson 3. It's actually lesson 1, session 3, and I'm going to be naming our homework by that. So if you see that homework is called lesson 1, session 3 and not like 9-3 or whatever, or 8-31, whatever day it is, don't panic. I'm just going to start naming our homework based on what lesson and session we're doing, okay? Okay. So today we're going to use area and scale factors to find real actual area versus blueprint area. So if you can see right here, we've got a blueprint. And this is kind of similar to what we did in class, where we made a blueprint of the classroom and got to make our dream classroom. So what we're going to do is we're going to use this blueprint to find the area of this museum or natural history museum in real life. So let's go ahead and read this. A blueprint for the floor of a natural history museum is shown. The scale of the museum to the blueprint is 20 yards to 1 inch. Okay, so similar to like what we did in class, we did 1 square equals 1 foot in real life. So this is a little different. They are using measurements instead of counting the squares. What is the area of the floor of the actual Great Hall? Okay, so if I were to do this, I would think of like, okay, so if I have a number line here, and this is for inches, okay? This is the blueprint in inches. And let's have the same timeline below. And this is going to be actual, and this will be in yards. Okay, so if I have 0 inches on the blueprint, how many actual do I have in real life? Well, that's easy, 0. Now, I do know 20 yards is 1 inch. So I'm going to say, okay, so if that's the case, if I have 1 inch, I know that's 20 yards, right? Okay, well, with that logic, how much is 2 inches in real life? Well, it just doubles, right? So this is 20, so then that would make this 40 yards in real life. Now, with using that doubling logic, can I also now go find how much a half is? What is half of 20? Half of 20 is 10. So I know if it's a ½ inch on the blueprint, it's going to be 10 yards in real life. Now, I'm going to go even further and split it again and say, well, if that's the case, then how much is 1/4 of an inch? And the reason why is because we are kind of dealing with fourths. Do you see that? We're dealing with 1/4 inches. So now I'm going to split it again. What is half of 10? Half of 10 is 5. Okay, so far what I've figured out is I have found that 1/4 of an inch is the same as 5 actual yards. Okay, 1/2 of an inch is the same as 10 actual yards. It looks like I need to keep going because we're using 3/4 of an inch and we're using 1 3/4 inch. So I'm just going to keep going. If each of these intervals is 5, can't I also say that this is also 5? If I say 3/4 of an inch. Okay, so that'd be 5, 10, 15. So I'm just going to keep splitting it into fourths and pretending each one is worth 5, okay? So here's a fourth, here's a fourth. So if that was the case, this would be 25, 30, 35, and then 40. So this would be 1 and 1/4, 1 and 1/2, 1 and 3/4, 2. Okay, so we've made kind of like a little number line to kind of show us how things line up and how they're equal, okay? So we know 20 yards is 1 foot. That's how we started all of this. We knew that 1 yard is 20, or 1 inch is 20 yards. So from there, I split it in half, and I said, well, what's half of 20? 10. And then I split that in half, and I said, what's half of 10? Well, it's 5, okay? So that's basically how we got here. Now, let's go ahead and think for a second. When I find area, I multiply the length times the width, okay? So I'm going to multiply 1 3/4 times 3/4, okay? Now, if I multiply those two, I'll get the area of the blueprint Great Hall. But I want the area of the actual Great Hall. So before I multiply, let's change this and this into yards. Now I could convert. However, I made this nice little timeline down here. So I'm going to go ahead and match these up. I have 1 3/4 inch, so now I'm going to go find 1 3/4 inch, which is right here, and it lines up with 35 yards. And then I've got 3/4 of an inch, so let me go ahead and grab a different color. 3/4 inch right here lines up with 15. So in real life, the dimensions of this Great Hall are actually 15 by 35. Okay, so now let's just multiply those two things. 15 times 35, I'm just going to go ahead and do it really quick. 15 times 35 equals 525. And now how do we label that? Yards, and its area, so we have to say squared, because we're basically finding out how many little squares can I fit in that flooring, okay? So I can fit 525 yard squares in the actual Great Hall. Okay, so that's one way you could find the answer. Another way could be to just multiply. We could take 3/4 of an inch and times it by 20 and find 15. And we could take 1 3/4 and times it by 20 and get 35. Okay, and then after that, then we could just times both of those together and get 525 yards squared. However, timelines like these are super easy to make, and to me, they just make more sense. Like, you can visually see it. Okay, let's turn the page. Now they're kind of showing us a good little example of basically what we just did. Let me grab my handy dandy laser pointer. A blueprint for the floor. Okay, we're not going to reread that because it's the same question as the one on before. But here's how we can model it. You can use a table of equivalent ratios to find the actual dimensions. Now, a table of equivalent ratios, that is 100% what we just did right here. It's just not in a table, it's in these nice little timelines, okay? But a table of equivalent ratios is the same thing. They start out with what they know. We know that 1 inch is the same as 20 actual yards. And then they just go ahead and split out all the different fractions, okay? The actual floor is 35 yards by 15. When you multiply those, you get the answer. So you can use a scale factor to find the area of the actual floor. The scale from the blueprint to the museum is 20 to 1. Now, this is super important how they wrote this. 20 to 1. Okay, that is called a ratio. And when you do scale drawings, there are ratios. So for example, the scale drawing that we did of our classroom would have been 1 to 1. Now what that means is we did 1 square equals 1 foot in real life. Not that it's like 1 to 1 feet to feet, or else that would have been a huge piece of paper the size of the classroom, okay? So our scale for this blueprint of the museum is 20 to 1. 20 is the length of the actual floor. So if you took this fraction, I'm going to change it to a decimal, 1.75, and you multiply by the scale factor, which is 20, you would get what they said over here, which was 35. And if you took this and changed it to a decimal, I'm going to say 0.75 times 20, you would then get 15. Then you'd multiply both of those to get the area, okay? So here's a way to do it in like a chart or a table or like a picture, okay? So if you need to try it with a picture, there's your answer. If you want to do it mathematically, here's your answer, okay? Hi, dinosaur. Okay, let's go ahead and do the problems together on Connect It. I'm gonna go ahead and move my paper. Boop. Okay. Sorry, I got sticky notes all over the place, guys, in real life. All right, let me grab my pen. What is the area of the floor of the actual Great Hall? All right, we already solved that over here, and that is 525 yards squared. Don't forget the label, super important. Look at the second model it, which is the math right here. What does the scale factor mean in this situation? So we said the scale factor was 20 to 1. Remember, 20 yards in real life is the same as 1 inch on the paper. So basically what the scale factor means is just that. We could say for every why does every look so weird? I'm going to rewrite that correctly because it looks silly. For every 20 yards in real life, you would draw that 1 inch on a blueprint. Sorry guys, I kind of ran out of room. So for every 20 yards in real life, you would draw it as 1 inch in the blueprint. Number 3. The scale from the museum to the drawing is 20 to 1. Another scale from the museum to the drawing is 400 to 1 inch squared. Explain why. Okay, so why can I say the same scale for the same picture could be 400 yards squared to 1 inch squared? Okay, so let's think about it. We know that squared has to do something with area. When we talk about area, it means that we are multiplying by a length and a width, correct? So let's say that on my blueprint, I'm going to go back to my blueprint for a second. I'm going to erase this stuff. Okay. Let's say we're talking just in my blueprint for a second, okay? They're saying that 1 inch squared is to 400 yards squared, okay? So let's say this is just the blueprint. Let's say an inch is about like here. I mean, it's not in real life, but let's say that's an inch, okay? 1 inch by 1 inch. What's 1 times 1? 1. So what they're doing is they're saying if you take the area of the normal 20 to 1, if you take this and make it an area, you would take 20 times 20 and get 400, and you would take 1 times 1 and get 1. But you wouldn't just say 400 to 1, you'd have to put the squared in there to show that we used it as area, okay? So it's kind of a silly question. So explain why we could say 400 yards squared is to 1 inch squared. Well, we could say oops, that's not a good why. You can take the scale 20 to 1 and you can represent it with area. I'm going to say change it. By multiplying 20 times 20 to get 400, and 1 times 1 to get 1. But then you'd have to say the squared, so it would be 400 yards squared, because it's area, oops, 2, erase, oops, took away my 2, to 1 inch squared. Kind of a silly question, but you can do it that way. All right, the area of the Great Hall in the blueprint is 1 5/16 inch squared. Why does multiplying the blueprint area by the scale factor 20 not just give us the area of the floor of the actual Great Hall? So, in the very beginning of this, why couldn't I, I'm going to erase my doodles. Why couldn't I have just multiplied this by this and then got 1 and, what did they say? 1 and 5/16. 1 and 5/16 inches squared. Why couldn't I have just taken that and then changed that into yards like on my scale? Well, since you multiply each blueprint dimension by 20 to find the actual dimension, you have to multiply the blueprint area by the scale factor twice to find the actual area. So since we multiplied this by 20 and this by 20, and then multiplied those to get the area, like we did right here in the math section, okay, we took this and we multiplied it by 20 right here and got 35. We took this and we multiplied it by 20 and got 15. Then we multiplied 35 by 15. So basically what they're saying is you can just take 1 and 5/16 and multiply it by the scale factor. But you'd have to multiply it by the scale factor again because both of the length and the width both had to get multiplied by 20. So why can't we do it? Well, because each dimension, length and width, needed to be multiplied, not just the total. Each dimension, length and width, needed to be, I'm going to say multiplied by the scale factor. Hold on, my son just woke up, so I have to turn off the baby monitor. Each dimension, length and width needs to be multiplied by the scale factor. Okay, you can't just multiply it once by 20 and be like, ta-da! You have to do it twice because the length and the width needed to be multiplied by 20. Number 5. How is finding an actual area from the area in a scale drawing similar to finding an actual length from a length in a scale drawing? And how is it different? Well, when you're finding the scale factor, it is similar because you can multiply by the scale factor. But for the length, we only multiply by the scale factor once. For the area, we have to multiply it twice. So basically, it's asking like right here. It's asking, so how come? How come they're different? You know, I can still get the same answer, but how is it different? Well, if you're doing it just from the length and the width, then you multiply it by 20 just once each. If you're multiplying it from the area, then you have to multiply it twice because it's a length times a width, okay? To make that easy, we're going to say if you are converting the area, then you multiply it twice. If you're just going to multiply it by the length and the width, you just multiply it once each. If you're converting the area, you need to multiply it twice by the scale factor, which in this case was 20. And if you're solving it by changing the length and the width, then you would just multiply it by 20 once each. Ooh. Solving, S-O-L-V-I-N-G. If you are solving by multiplying to just, sorry, my J got crazy, just the length and the width, then you only multiply it once each. Okay, reflect. Think about all the models and strategies you have discussed today. Describe how one of them helped you better understand the relationship between an actual area and the area in the scale drawing. Okay, so this question is more of a opinion. When finding the answer to this, did you prefer this nice little like timeline where we got to match up all the numbers? Or did you prefer the math way where they were just like, well, duh, just take this times 20, and then multiply those? Okay, which way did you prefer? Did you prefer the table? We're going to call this a table, even though it's more like a chart or a timeline. Did you prefer making a table and lining up? Which I kind of did, just because I like to visually see it. Or did you prefer the math way by just multiplying and then multiplying them together to get your answer? Okay, which one did you prefer, and which one would you probably have used naturally right away? All right, guys, let's go to the next page. You guys can answer that one on your own. Pause the video if you need to. Number 7. All right, get my pen. The scale from a playground to the scale drawing of the playground is 4 meters per centimeter. Okay, so I know my scale factor is for every 4 meters in real life, that's 1 centimeter on the drawing. The length of the drawing of the playground is 5.3 centimeters and the width is 3.8. What is the area of the actual playground? Show your work. You know, I think I'm going to go about this the math way instead of making a chart. So what I'm going to do is ask myself, what is the scale factor? Now, the scale factor I know is 4:1. And because it's a unit rate, remember when we talked about unit rates last week? A unit rate is 1 of something. Because there is a unit rate in here, there is 1 of something, I can say that 4 is the scale factor. So for every 1 centimeter, I multiply it by 4 to go up and up and up. So since I know that, I'm going to take 5.3 and times it by 4, and I'm going to take 3.8 and times it by 4. Then I'm going to times their answers together, okay? Okay, so let's go ahead and do the math. I'm going to do the math over here because it says to show your work. I'm just going to zoom in. So I've got 5.3 times 4. 4 times 3 is 12. 4 times 5 is 20, plus 1 more is 21. 1 space, 1 space. Okay, so I know there's going to be a 21.2, and then the other dimension was 3.8. 3.8 times 4. 8 times 4 is 32. 4 times 3 is 12. 13, 14, 15. Move it over once. Okay, not done yet. So that 21.2 and that 15.2, that is my new dimension. So if I was outside right now, the playground is 21.2 meters by 15.2 meters. So now what is the area? Now I have to take both of these two, length and width, and multiply them, okay? So I'll do that over here. 21.2, 15.2. Times them out. 2 times 2 is 4. 2 times 1 is 2. 2 times 2 is 4. Placeholder 0. 5 times 2 is 10. 5 times 1 is 1 plus 1 is 6. 5 times 2 is 10. 2 placeholder zeros. 1 times 2 is 2. 1 times 1 is 1. 1 times 2 is 2. And then add it all up. Okay, now when you multiply with decimals, you count how many places in at the very end. So we go 1 and 2. So that means in my answer, I'm going to go 1, 2. So my final answer is the area of the actual playground is 322 and 2400th meters squared. Now that's not my final answer on my paper because I need to label. So I'm just going to rewrite it right here. Remember, squared because it is area. All right. Number 8. A square has an area of 144 feet squared. In the scale drawing of each square, each inch is 6 feet. What is the area of the square in the drawing? Okay, so I know that's a lot of information, but let's break it down. When I saw 144, my brain automatically said, oh, that's a perfect square. A perfect square is when you should have your perfect squares memorized. So basically a perfect square would be like 3 by 3 equals 9. If this was 4 by 4, it would equal 12. Okay, so basically what I'm asking you is what times what is 144? Well, if you know your perfect squares, it's 12. 12 times 12 is 144. You just got to have that one memorized, okay? So already when I saw 144, I thought, oh, 12 times 12. So here's my square. I know its length and its width are 12 because 12 times 12 is 144. Okay, so this is in real life. It would be feet. That's a big square. Okay, but now we're going to make the drawing, and the scale factor says each inch is 6 feet. So we're going to say 6 feet to 1 inch. So now this is my new scale factor, okay? So now I'm going to take my giant real life square and shrink it down to this little piece of paper, okay? So if I'm going from a little piece of paper to my giant square, I would multiply, right? I mean, that's what we did with this park, isn't it? Didn't we take the playground and multiply it by the scale factor of 4 and to find the actual size? Well, what happens when we know the actual, but we need to, shrink it down? So what we need to do then instead is we need to divide, okay? So what I would do is I know this is 6, I know this is 12, so I'm going to divide by the scale factor because I want to shrink it down, right? Dividing makes things smaller. So I'm going to divide each side by 6 instead of multiplying. That would give me, the 12 divided by 6 is 2. Okay, so on my little piece of paper, I'd go 2 inches by 2 inches, and then I'd have this tiny square, okay? But it says, what is the area of the tiny square on your drawing? Okay, so what is 2 times 2? 4. Ta-da! D is our correct answer. So basically what I want you to get from that is if we're going from small on the paper and we want to go big into real life, then we multiply. If we're going from big into real life and we want to go small on the paper, we divide. Make sense? Okay, last question. Number 9. Below is a scale drawing of the side of a ramp at a skateboard park. The scale from the drawing to real life is every 2 centimeters is actually 12 inches in real life. What is the area of the actual side of the ramp? Show your work. Okay, let me go ahead and erase my thing up here because I want this whole space for myself. Okay, so we got a lot we got to talk about here. For one, how do I find the area of like a triangle like this? When I'm finding the area of a rectangle, I would just take the length times the width. Well, a triangle, especially a triangle with a nice pretty little 90-degree corner, is just half of that, right? So basically I would treat this as if it was a rectangle, but then by the end I will divide it in half to get just that triangle, okay? We'll worry about that towards the end. We won't worry about that right now because what we need to actually worry about is the scale factor, okay? The scale factor says every 2 centimeters is 12 inches. Is that a unit rate? No. Why is it not a unit rate? Well, we talked about unit rate meant 1 of something, correct? Look back up here. This was a unit rate because there was 1 of something. It doesn't matter if there was 4 as well. There has to be 1 of something for it to be a unit rate, okay? Even if we go back a little bit over here. Did we have a unit rate of this? Yeah, we had 20 yards to 1 inch. That was a unit rate because there was 1 of something. Now, I need a unit rate for this because there's not one of something. If I were to think of my timelines, like I did very first page, if I said this was 2 inches right here, this is 2 inches and it equals, or 2 centimeters, sorry, this is 2 centimeters and it equals 12 inches. What's half of that? 1 centimeter. What's half of 12? 6 inches. So do you see what I just did? I just now took the scale they given me and I went and I found a unit rate. I'm going to rewrite it because now it's not 2 centimeters to 12 inches. Now it's 1 centimeter is to 6 inches. Now that I have a unit rate, now I can use that 6 inches to find the actual, okay? So what I'm going to do is I'm going to take this and multiply it by 6, and I'm going to take this and I'm going to multiply it by 6, okay? Because now I have a unit rate. 6 times 2 is 12. 6 times 8 is 48. But now that's just the new length and width. I need to now find the area. So here's where we're going to have to draw that pretty little rectangle, okay? I'm going to get rid of some of my chicken scratch here for a sec. I'm going to redraw this into a rectangle. Boop. So if I found the area of the whole thing, I'm going to rename these. This is not 2 anymore. Now this is 12. This is not 8 anymore. This is 48. If I were to take 12 times 48, I would get, let's find out. 8 and 8 is 16. 8, 9. Placeholder 0. 4 times 2 is 8. 4 times 1 is 4. Add them all up. 576. Okay, so I'd get 576, but you guys, 576 is the area of the whole caboodle, right? That's the whole thing. I don't want the area of the whole thing. I want the area of only like half of it. So to do that, I'm just going to divide by 2. So 576 divided by 2. Ooh, let's see here. 5 goes into 2, 2 goes into 5 twice to get 4. Subtract it. 1, bring down our 7. 2 goes into 17 8 times, it'll be 16. Subtract it and get 1, bring down our 6. Ooh, this is going to turn pretty. No extra anything. Yay. Okay. Woohoo. 288. What does that mean? That means in real life, this ramp has an area of 288 inches squared. Not a very big ramp, but there you go. All right, guys, that is the end of your lesson for today. So we will do the green pages in class. Make sure you have all of this filled out. This page, page 18, is the page you will want to scan and enter into the slideshow to prove that you did your work today. All right, see you in school.